Hey, Don and Edgar, this is John Bergen. Hey, let's see if we can answer your question. I think it's a cool question. So if you've got this tiny nitrogen atom, if I understand your question, oops, tiny nitrogen atom, and if it were to be blown up to size of the Earth, and it was an equal in weight, how big would the nitrogen have to be blown up? So it's kind of a weird question because it's got some volume and some mass. So this is kind of what I was thinking. I had to look up some numbers. So the mass of a neutron, or of a nitrogen atom, so I'll call that M of nitrogen, is equal to 2.32 times 10 to the minus 26 kilograms. It's very, very light because it's very, very small. The volume of a nitrogen atom, this is how big it is, right? What the distance across. So if you have the atom as a sphere, it's the volume. It's like the whole size of the ball. It is 1.14 times 10 to the minus 30th cubic meters. That's a very, very small number. I had to kind of figure that out. And then what we can do is we can set this up in a proportion. We can look up the mass of the Earth, and I looked up the mass of the Earth, and the mass of the Earth is 5.90 times 10 to the 24th, a very big number of kilograms. Of course, that's the mass of the whole Earth. And what you're trying to find is what I'll call the volume that it would have to be. So now I do some math. What I do is I do equivalent fractions, cross multiplication. So if I cross multiply this times this equals this times this. So if I take 5.90 times 10 to the 24th kilograms, and then I multiply by 1.14 times 10 to the 30th meters cubed, that's this cross right here, that would be equal to 2.32 times 10 to the 26th kilograms times the volume you're trying to find. Well, when you do all that math, you basically divide both sides by 2.32 times 10 to the 26th, right? To the negative 26th. Pardon me, not the 26th. And then you take 2.32 times 10 to the minus 26th. These cancel, and you end up with this number. So now I did the math here for you. You can get a calculator out. So the volume that the nitrogen atom would have to be would be, I converted it for you, will be equal to 4,116 kilometers. Pardon me, that's not correct. It's going to be 2.9 times 10 to the 20th meters cubed. Now, to get a perspective of how big that is, I said, well, what would be the volume of that? So if you remember your equation from algebra class, volume is 4/3 pi r cubed. I want to figure out what is the radius of that object, right? So r is what I wanted to solve for. So if you do some reverse math, you can say r is equal to the cubed root. That's kind of confusing if you're younger. 3/4 v divided by pi, 4 pi, pi. So when you do this math, you find r, this is that number, 4,116 kilometers. Now to give you a perspective on that, the diameter, or the radius, pardon me, the radius of Mars is 3,397 kilometers. So this is a little bit bigger than Mars, and the Earth's radius, as it turns out, is 6,378 kilometers. So it's kind of closer to the size of Mars, a little bigger than Mars, and quite a bit smaller than the Earth. So does that answer your question? I hope so. It was fun solving your problem. Have a good day.